If you've ever tried to build a piece of software, you know the real challenge isn't just writing code, it's making all the pieces fit together. Get those relationships between your classes right, and your code is a dream to work with. Get them wrong, though, and you're heading for a world of pain. Today, we are diving deep into those critical relationships, the very backbone of great software design.
So, here's our game plan. We'll start by stocking our design toolkit with the 4 core ways classes can interact. Then we'll cover a golden rule for using them, called the Liskov Substitution Principle. We'll look at a super common trap you can fall into with inheritance, and then the elegant way out using composition. Finally, we'll wrap it all up so you know exactly which tool to grab for the job.
Okay, so first things first. Before you can build anything great, you need to know your tools. In object-oriented programming, there are really 4 fundamental ways that classes can connect with each other. Kicking things off with the one everybody learns on day 1, inheritance. This is your classic is-a relationship.
It's a really powerful idea, right? A dog class gets all the stuff from an animal class for free, so you don't have to rewrite code. On the surface, it seems super simple and efficient. But, and this is a big but, this simple tool is hiding some really nasty traps if you're not careful. We'll get to that.
Next up in the toolkit is composition. Now this one represents a has-a relationship, and trust me, this is where things get really flexible and powerful. See the shift? A car isn't a type of engine. A car has an engine. It might seem like a small detail, but this lets you build big, complex things out of smaller, interchangeable parts. It's like building with Legos, and it gives you incredible design freedom.
Then we've got aggregation. You can think of this one as composition's more laid-back cousin. It's also a has-a relationship, but there's a really important difference.
So, if the company goes out of business, the departments don't just vanish into thin air. They could, in theory, exist on their own or become part of another company. It's perfect for modeling those looser connections where things are grouped together but not tied at the hip.
And that brings us to the final tool in our basic kit, association, which is pretty much the most general-purpose relationship you can have.
This is just a simple link. A student isn't part of the course, and the course definitely doesn't own the student. They're just 2 separate things that know about each other for a while. It's the most basic way to show that 2 classes interact. All right, so we've got our 4 tools: inheritance, composition, aggregation, and association. But, just having a hammer doesn't make you a carpenter. You need to know the rules. And when it comes to these tools, the most important one, especially for inheritance, is the Liskov Substitution Principle. We'll just call it LSP.
Okay, I know, that definition sounds pretty academic and formal. But the core idea here is incredibly practical. It's all about creating what you might call a contract of trust between your classes, so your code doesn't do surprising, unpredictable things. So here it is in plain English. If you have a chunk of code that's expecting to deal with an animal, it should work perfectly whether you give it a dog or a cat. The code shouldn't have to stop and ask, hey, wait a minute, what kind of animal is this really? The dog has to honor the promises made by the animal class. It's a contract.
So, theory is great, but let's see where the rubber meets the road. We're going to look at how that first tool, inheritance, can get us into a whole lot of trouble by breaking this golden rule. And it happens so easily.
And here is the classic example that trips people up all the time. Logically, an ostrich is a bird, right? So it seems totally natural to make our ostrich class inherit from a bird class. But here's the trap. Our main bird class probably has a fly method. And, well, you see the problem. Ostriches don't fly. So what happens? Some other part of our program, which thinks any bird can fly, grabs an ostrich object and tells it to fly, fly. And kaboom. The whole thing just crashes. Our ostrich broke the contract. It violated the Liskov Substitution Principle because it didn't behave like its parent class promised it would. So what do? Just live with fragile code that might blow up? No way. We just need to go back to our toolkit and pick a smarter tool for this job. And that tool is composition. Instead of forcing every single bird to have a fly method, we're going to treat flying as a separate capability, an optional extra. We can define this capability using an interface. Let's call it iFlight. Now, only the birds that can actually fly, like a sparrow, will get this capability. Our ostrich is still a bird, but nobody expects it to fly. No broken promises, no surprise crashes. Problem solved.
This is why composition is so amazing. Let's go back to that car example. Our car class isn't locked into one specific kind of engine. It's just built with an engine. So we can easily create a car and just plug in an electric engine.
And just like that, with zero changes to the car class itself, we can pop in a gasoline engine instead. The car doesn't care. As long as the engine object fulfills the iEngine contract, everything just works. That is LSP in action, and it's all thanks to the incredible flexibility of composition.
And all of this brings us to the most important point. Becoming a great developer isn't about always reaching for the most complicated tool. It's about mastering the basics and knowing exactly which tool to use and when.
So think of this chart as your cheat sheet. And notice the big takeaway here. Use inheritance, but use it carefully, and only for true is-a relationships that don't break that contract of trust. For pretty much everything else, you should favor composition. Building your software from smaller, independent parts is almost always the more flexible, stable, and future-proofed approach. So if you only remember a few things, make it these. Be really cautious with inheritance. When you want to build things, think about building them out of other things first. That's composition. And above all, never ever forget that contract of trust. Your objects have to behave the way they promise they will. And that leaves us with one final question for you to think about. Now that you know exactly what to look for, what flying ostriches, what broken promises are hiding in your own code right now, just waiting for the chance to cause a crash?